Hello! So today we're going to be talking about rational exponents. And what I mean by that is that you've got an exponent that essentially is a fraction. It is a ratio, hence rational exponents. So suppose we have something like x to the power of 1 over 2. Let's think about that for a moment. If I've got x to the power of 1 over 2, and I were to try and get that equal to something that is x to the 1, well, think back to your rules of exponents. If I'm multiplying two things with the same base, then I can just add them. So 1 over 2 plus some other number, I'll call it a. I just want to make sure that I can see all this. All right, oh, yes I can. All right, very good. Just double checking, thank you. 1 over 2 plus a is going to give us 1. Well, what plus 1/2 will give us 1? 1/2. So 1/2 plus 1/2 equals 1, right? Stick with me, here's where I'm going with this. So if I have x to the 1/2 times x to the 1/2, that should give me x to the 1. Because x, if we follow the rules of exponents, I've got two things with the same base multiplying each other. This is x to the 1/2 plus 1/2, which is equal to 1. Yeah? That makes sense. Think about this then. I've got two values then that when multiplied by each other equal x. What are the two numbers? What number times itself is equal to x? In other words, what number, I'll just substitute b, squared is equal to x. Okay, b is equal to x to the 1/2, because that's squared. The only thing that would make this work would be the square root of x. Yeah? The square root of x squared is going to equal x. And that is exactly what this means. If you have a rational exponent, then it's really talking about some sort of root. Let me erase this, so take that down in your notes. And specifically, look at what's in the denominator. So if I have x to the 1/2, that's simply going to be the square root of x, because I've got a 2 in the denominator. If I've got x to the 1/3, that is going to be what is called the cube root of x, which means that if I take the cube root times one more cube root, because it's the cube root, not the square root, then that will give me x. You can think of this, and you can even think of this. This is just another way of saying, if this is x to the 1/3 times x to the 1/3 times x to the 1/3. Another way to rewrite all of this is x to the 1/3 times to the 3rd power. Again, think of your rules of exponents. If you know those, all of this fits together. X to the 1/3, that quantity to the 3rd power, you would distribute the 3. So this becomes x to the 1/3 times 3, which again is x to the 3 over 3, which equals x to the 1. All that is in there, yes? Okay, we just want to make sure it's visible because shading and all that stuff from the light. And this works for the positive integers when we're talking about the roots. Similarly, if you've got x to the 1 over n, where n is a positive integer, that will give us the nth root of x. So far, so good. If you want to make it a little bit more complex, get this down so I can erase. If you want to make it a little bit more complex, and you can declutter it too, if you've got x to the, let's say, 2/3, okay? This is the same thing as saying x, we can break it down just like we would break down a fraction. 2/3 can also be written as 2, technically 2 over 1, and the same thing as 2, right? Times 1/3. So we can rewrite this as 2 times 1/3. This x to the 1/3 is the same thing as the cube root of x, but then we're going to square it. Yeah? Or it really doesn't make a difference. You can even say you can square it first. But it's still x to the 2/3. It's a cube root. And then it's, the numerator is for the variable there. Or you click on the outside unit. It ends up being the same thing. Because it all follows our rules of exponents. All right, so I think that's a good introduction to this. It's good to play around with this some. And if anything looks weird, now is a perfect time. Write it down in your notes, bring that question to class, and we shall review. I hope this was fun. Have a great day.